Hi everybody. In the previous video, we learned about the interface of Mathematica, including the Mathematica notebook file. The next logical step is learning to communicate with Mathematica. In the second hands-on video, Cliff Hastings introduces two assisted approaches to the interaction with Mathematica, namely free-form input and palettes, and one direct approach.
Mathematica offers a variety of methods to enter calculations, making it really easy to get started. Let's start by making a new section cell. I'm going to do this by clicking at the bottom of my notebook to make sure I have the cursor in the right place, and then choose Format, Style, and Section. And I'll call this section Means of Starting. I'm going to press the down arrow key to get my cursor ready, and now I'll create a new subsection by using the keyboard shortcut Alt-5 or Command-5 on Mac, and let's call this one Freeform Input. This time keep your cursor inside the cell instead of pressing the down arrow key, and I'll explain why in a second. I want to make two more subsection cells because there are three ways to enter input in Mathematica, and I want to have a subsection for each one of them. We already have our first one made, so now I'm going to hold down the Alt key or Option on Mac and press the Return key. You'll see that Mathematica has created a brand new cell and the cursor is inside, ready for us to start typing. So let's type Wolfram language. You'll notice that the text for Wolfram language looks the same as free-form input. That's because pressing Alt and Return together is a keyboard shortcut that tells Mathematica to create a new cell of the exact same type as the one you're currently in. This is a really handy shortcut if you're going to quickly outline a document and then fill in the contents later. But really, with all of these different ways to enter input, just find the method or methods that you like best and use them accordingly. If you moved your cursor out of the Wolfram language cell already, then place it back in. And let's use Alt and Return together, that shortcut again, to create one more subsection cell. This time, we'll call it Palettes. Okay, now let's put the cursor underneath freeform input by using the arrow keys to get it where it needs to be, and let's start doing some calculations. Mathematica and other Wolfram products are unique in that they allow you to immediately start getting work done by giving commands in plain English instead of having to learn commands or syntax first. One of the ways you can do this is by clicking on that Cell Insertion Assistant plus sign and choosing freeform input. When you do that, you'll see an orange square with an equal sign appear in the cell, and the cursor is blinking to the right of that. That equal sign means that you can tell Mathematica to do something by using plain English. So let's type integral of cosine of 2x, and then hold down the Shift key and press the Enter key. This Shift and Enter combination tells Mathematica that we are finished entering input and we are ready for it to run the calculation. And when we do that, we'll see the result along with some other information as well. Okay, so let's look at what happened when we pressed Shift and Enter together. The first thing you'll see is that below the freeform input we entered is a command that Mathematica translated our input into. Mathematica is able to do this by taking the freeform input that we entered and sending it to the parser running on servers here at Wolfram. The parser says, okay, you asked us to do this, and here is the command for doing that directly in Mathematica. And it sends that command back to your Mathematica session along with the result. In this case, that result is 1/2 sine of 2x. Now, freeform input makes it so easy to get started with Mathematica because the parser is really good at understanding what you want and giving you suggestions for the right commands. This means you can dive right in and start getting work done, but having it show you the commands that are being used lets you start to slowly absorb how you might do things directly by typing in the commands yourself. Now, it's important to point out that you need to have an active internet connection to use freeform input. If you don't, it's fine. You can still use Mathematica directly, and we'll see how easy that is in a few minutes. Now, along with the results, you may have seen a little bar pop up. This is called the suggestions bar, and it contains some suggestions for things you might want to do next. If you don't want to see this bar, you can click the X icon to hide it. And similarly, if you don't see this bar and if you want to see it, you can click the arrow then to show it. The suggestions bar is really useful for a couple of reasons. First, it's smart, so if you don't have it hidden, you will still only see it when your cursor is in an output cell. So if I go up to this freeform input section cell and click to set the cursor there, the suggestions bar disappears. But if I click back in the output cell, then the bar reappears. Second, the suggestions bar is context aware, so it only shows suggestions that are relevant to the type of output it's currently looking at. So if your output is textual in nature, the suggestions bar is going to give you options to format the text, but it won't give you options for things like finding a numerical approximation, since of course that wouldn't make sense. And then finally, the suggestions bar is adaptive, so it learns your specific workflow and the type of operations you like to do, and it will tailor its suggestions accordingly. So the more you use it, the more useful it then becomes. So let's look at how to use the suggestions bar. We see that one of its suggestions is to take our result and simplify it. So let's choose this option, simplify, by clicking on it. When we do that, we see that Mathematica simplifies our expression to cosine of x times sine of x. That's pretty neat. And like with freeform input, we don't need to know any Mathematica commands to do this. We just make choices from the suggestions bar that were provided to us. Let's take a look at another example of using freeform input and the suggestions bar. Since we are ready to create a new input cell, let's press the equal sign as our first step. When we do that, you'll see that we get the same little orange icon that we had before, and now we are ready to give our command in English. So let's type plot of 1/2 times sine of 2x to visualize the result we got in that previous step. Now, as before, Mathematica pings the Wolfram server. It translates our request into a precise command, and it returns that command along with the actual result. So let's take a look at another feature of these results. You should see a little orange plus sign to the right of the freeform input line, and you can click that to see additional results that might be of interest. So let's click that icon and expand the additional results for the integration we performed. You can see that there are related items that might be of interest. For example, I can click Step-by-Step Solution to see the manual steps you might take to solve this integral by hand. And when you're done exploring, you can click the icon again to hide those results. Now let's go back to our current result with the plot of the integral. And let's place the cursor over the command that was returned, which starts with plot. You should see a little pop-up that says Replace cell with this input. And when you do, click on it. When you do that, you'll see that the freeform input is thrown away, and you are left with just the command and the result. Now that we have the command, let's make a change by replacing the domain to be from -10 to 10 instead of what it said originally, and then press Shift-Enter to evaluate. The plot should update based on the new values that we have typed in. This time, the suggestions bar offers commands that are relevant for visualizations. For example, by clicking Theme and using the menu that pops up, we can change the theme to marketing and then click Done to apply a nice style to that graphic. As an aside, you'll also see that these cells have little in and out labels with numbers to them on the left. That's because Mathematica keeps a running list of the calculations that have been performed during a session. A cell with input is called, not surprisingly, an input cell, and its matching partner is called an output cell. Like before, you can double-click cell brackets to hide and show cell contents, and input and output cells are really flexible. You can double-click an input cell to hide the input. You'll see that cell bracket with the little triangle again, or you can double-click an output cell to hide the input, in which case you get a cell bracket with a triangle on the top, indicating that there is something hidden above the displayed cell. Hiding input can be especially useful when you want to create a clean-looking document that only shows the results, but not any of the commands used to create those results. Okay, so what happened when we threw away the freeform input and edited the command? Well, we were using the Wolfram language directly. The Wolfram language is a collection of thousands of commands and functions for doing all sorts of things, and it's the programming vocabulary, so to speak, that powers all of the Wolfram products. Freeform input is great for getting started, or even the casual use of Mathematica. But once you want to start building up more sophisticated commands or writing programs, you'll want to start using the Wolfram language directly, because you'll have the flexibility and power to tell Mathematica exactly what you want it to do. Luckily, the Wolfram language is very high level, which makes it really easy to get started, and there's just a few things you need to remember. So let's go back to our notebook and make a subsection below the Wolfram language section and call it 4 basic rules. Now let's start a new cell, choose other style of text, and select item numbered, and enter our first rule, which is capital letters on all command names. Let's use the Alt and Enter shortcut then to enter the second rule, which is square brackets surround function arguments. What this means is if you see a capitalized word like plot and then it has a pair of square brackets next to it, then plot is a command, and inside of those square brackets are the specific pieces of information needed to make plot do something in particular, like visualize the graph of the function 1/2 sine of 2x over the domain -10 to 10. Okay, so let's use Alt and Enter again to input rule number 3, which is curly braces are used for lists and ranges. Now, we've already seen an example of this because when we changed the domain to be from -10 to 10, they were between a set of curly braces. And finally, Alt and Enter one last time. We'll enter rule number 4, which is Shift and Enter to evaluate input. Now this last one is really important because Mathematica is a great tool for creating technical documents. So when you press that Enter key by itself, it will create a carriage return or a new line. So either use Shift and Enter together, or you can use the Enter on the numeric keypad, and this will tell Mathematica that you are ready for it to evaluate some piece of input. Now let's use the Wolfram language to do another integral. We know that the command to use is integrate, since that's what was returned by our freeform input command. So let's start a new input cell below our numbered list. This time we are not going to choose an input type. We are going to just start typing, and that's fine because by default Mathematica expects an input cell to contain Wolfram language code unless you make a different choice when you're creating your cell. Now as we start typing integrate, you'll see this pop-up menu appear, and it's narrowing down the list, the possible list of choices by automatically guessing the command we want to use. Now we can ignore it or hit the escape key to make it disappear, or we can use the arrow keys and press enter or point and click the mouse to select the command name we want. Once we do that, we see a menu with double chevrons, and clicking that shows us the possible ways to enter this command depending on what we want to do. So let's select the second one to calculate a definite integral r, and that pastes in a template for us to fill in. For the function f, let's enter x squared by typing x and then shift 6 to get the caret, and then 2 to raise x to the power of 2. And for the function variable, let's use x, and let's integrate over the domain -10 to 10, and then we hit shift enter to evaluate. We immediately get an exact result, which is 2,000 over 3. And Mathematica will always give you the most exact answer possible, depending on the command you have used and the type of arguments you have supplied. In this case, maybe what we are really after is the numeric approximation, so we can click numerical value to get a numerical result. We'll discuss this a bit more in the next video as well. Now, an important feature of the design of the Wolfram language is the coherence of how everything is developed. And as a result, once you know how to use one command, you know how to use a bunch of other ones as well. For example, you may have noticed the similarity between performing a definite integration and plotting a single variable function. Both ask for the function in question in a corresponding domain. If we go up to our integrate command, change it to plot, and then reevaluate, we get a new result without changing any of the other syntax. Now, I'm very much someone who likes to type, and I grew up using the Wolfram language directly in Mathematica before there were all these easier ways to get started, like with freeform input and the suggestions bar. And as a result, you'll probably see me typing in a lot of commands during the rest of this video series. But for those of you who like visual menus, there are also a set of point-and-click palettes that can be summoned by choosing them from the Palettes menu. When I use palettes, I tend to use the Classroom Assistant, since it combines the other two, the Basic Math Assistant and the Writing Assistant. But you can choose whichever ones you like in terms of if you are running low in terms of vertical space on your screen. Now you'll see that I have different sections here divided up into entering input, navigation of my notebook, performing basic commands, which are further divided into specific types of math like calculus and linear algebra, and options related to entering text and doing word processing. Let's enter the definite integral we just did, but let's use the palette, and let's enter in a typeset form. We can do this by navigating to Basic Commands, choosing the Calculus tab, and then clicking the button to paste in the typeset version of the definite integral command. This works very much like entering the input in 1D, so we click in the label for the lower bound, and then we type in -10. And then one neat thing about these templates is that you can press the tab key to jump to the next input. So let's enter 10 for the upper bound, and then press tab to jump to the expression. This time let's enter a typeset expression for x squared, and we can do that by going to the calculator section and choosing the superscript icon. So we'll enter x as the base, press tab to enter 2 as the exponent, and then tab to enter x as the variable to integrate with respect to. And finally hit Shift Enter to evaluate. We achieved then the same result as we did previously. Now using buttons on the palettes to choose commands will paste in the same templates we saw when we typed in the Wolfram language command directly. So that can be really handy to help remind yourself of the syntax. For example, let's go back to the basic commands section and choose the 3D tab, and then click Plot 3D. A template is pasted in, and even though we haven't seen this particular command before, let's see if we can fill it out using what we've learned so far. So for the function, let's enter sine, open square bracket, x plus y, close square bracket. And for the first set of arguments, we'll enter x, -3, and 3. And for the second set of arguments, we'll enter y, -3, and 3. When we evaluate, we see a three-dimensional plot of the surface of sine of x plus y. So now that we've seen a variety of ways to get started using freeform input, the suggestions bar, typing in Wolfram language commands, and using palettes, let's quickly explore one last resource to help you when you're first starting out, and that is the Documentation Center. You can get there by choosing Help in Wolfram Documentation. Once there, you can browse by topics, or if you're impatient like I am, you can just type in a search term. So if I type plot and then do a search, the first result I click on then is a reference page for the plot command. Now the first thing you'll see is a sort of dictionary definition of the command up at the top, and then additional sections like details and options, which are really nice for learning about the command in much more detail. I tend to jump right down to examples, and you'll find both simple and advanced examples here. So it's a great way to explore and learn about the different ways to use the command. Another nice feature is that the documentation is interactive. So if you go to this first example and change sine to cosine, for example, and reevaluate, I see the result immediately without having to go back to where I came from. And don't worry, because none of the changes you make while playing in the documentation are saved. So it's a great sandbox to try new things, and if you find an example you like, then you can copy and paste it back to your notebook to continue on with your project. Now, if I scroll further down this documentation page, I'll also see other commands that are related to plot in some way, along with links to tutorials for doing certain types of operations, and guide pages, which are portals to learning about general topics in Mathematica. And they all link to reference pages, like the one we have here, as well as other tutorials and examples. Okay, so now that we've built up a notebook and learned different ways to enter input, the next section we'll look at doing is exact and numerical calculations, assigning variables, and how to create your own functions as well.
Interactivity of Mathematica help is very useful for learning new features of Mathematica. Not only can you modify the existing cells in the notebook file, but you can also create new cells and use them for practice. Let us consider an example. Our current goal is to learn how the Mathematica plot function works. First, we open Mathematica Documentation Center, then type plot for the function we are looking for, and then click Enter. Now we are in the same file where we were a few minutes ago in Cliff Hastings' video. Only this time you will learn how to add new cells to this file and use them for your advantage. In this example, we will deal with two cells. The first cell depicts one function, sin x. The second cell plots three functions together. Let us begin. At the first step, we will highlight the first cell and use Ctrl-C to copy its content. Now, we move the cursor to start a new cell and click Ctrl-V. Now you can watch the rest of this video, read the comments, reproduce the actions. Good luck!